So they have to redirect those things to particular destination. I'm going to say in the factory itself. So the worker can take this and send it to the destination. So everything is done by robots now. So you see the AI getting mature and mature every day, and the human intervention is less. So everything is going to driven by AI with respect to embedded systems. So the thing is, so if you're learning AI, that's very awesome, and if you're learning embedded system, it's very good awesome actually in this case. That means you should learn embedded systems and the AI automation, which can take you in the some sort of AI mechatronics kind of job career in this case. So it's very important. This is the future actually in this case. So whenever you go in the embedded system, make sure that you should know about the AI as well. For example, the image recognition is one kind of AI application in the embedded systems where the robot itself understands what exactly the device it is, and based on it takes the decision and it automates everything. So it's very important aspect when it comes to cybersecurity as well. So that's what we understand. When you see this image, so you can understand this is the particular infrastructure we can see, right? So this is the OT you see over here. So let's understand quickly what exactly the jargons. Jargons is very important aspect. Whenever I see PLC, you have to imagine what I'm talking about. When I say HMI, what exactly I'm talking about. When I say the entire SCADA system, you should understand what exactly it is. So SCADA system is nothing but supervisory control and data acquisition. So what it means actually, it takes the data from the sensors and some part of networks and put it on the some UI based, or we can say graphical based interface over there, and you can see a lot of data is coming from all sensors. So there are Purdue diagram. We'll talk about typical network over here. So these sensors are getting plotted on the SCADA system, or rather we can say UI, in such a way that you can control it, you can understand it, all depending on the nature of the operation technology over here. Okay, so you can see this is the particular image where a lot of people are monitoring the entire SCADA systems over here, and based on that, they take a decision. Okay, that's what there. So it's basically when we talk about the SCADA system, we talk about the entire larger area. Actually, it's not about the 1 kilometer, 2 kilometers, or within that infrastructure. We're talking about the geographical spread area that comes around more than 10 kilometer, 100 kilometer, 200. Imagine that you are in the Delhi and your electricity is coming from some other area, right? I don't know much about the Delhi, but just imagine over here. So, like such as the electric power transmission is one example over here. We can see in the as part of the SCADA. Wind farm, again wind farm across the entire city or entire state itself. Civil defense, silent systems, and large communication systems is driven by the entire SCADA. If that particular SCADA goes down, what will happen? It will impact the entire country itself. So when we see in the war situation, what do you think? Where enemy going to attack at the time of war? Definitely this infrastructure. Nuclear plant, this infrastructure, it's very important aspect. It's a backbone of the entire nation, and that is the critical infrastructure also, right? And that's why the ICS infrastructure is very important part of this. So the HMI is nothing but human interface, human-machine interface. That means you are going to interact with a particular screen dedicated to that particular PLC or dedicated to that particular process that comes into the HMI. HMI comes into two parts, like software-based HMI. We'll see the action as well, and another is called as the what we can say, the hardware-based. So hardware-based, nothing but you have a touch screen, you can click, or you can have a mouse and you can make changes on the hardware based. Software based, that means it's kind of they have a database which is called as historian, and a lot of things comes into the picture, and that kind of data is pulled by one of the graphical user interface that is called as HMI in this case. So the definition of that HMI, it's all depending on the OT over here. Some things they call it as a HMI, some call it as a kind of software-based HMI. It's all depending on what kind of facility they have. So over here we can see this is the hardware-based HMI. So if you see, so on the entire screen you can see the entire process is going on. These are the touchscreen-based HMI. Nothing but these touchscreen-based HMI. In this case, they have some sort of RS-232 protocol, that is serial communication, and Ethernet-based protocol as well. So that particular HMI can, work on different protocols. All are depending on the infrastructure itself. Such as, I gave an example of the factories, right? Some automation factories, like where for example, vehicle manufacturing factories in this case. So they have big arms. They used to rotate the entire equipment from one to another, or displace the one device to another place. In this case, they use ARM-based. Literally, I'm talking about the ARM, where they can pick the device and put it somewhere else. In this case, so these are entire communication which use VID, PID, or serial motors. In this case, they controlled by EtherCAT. Okay, you understand Ethernet, right? So Ethernet-based protocol, TCP/IP, but they use EtherCAT. So this is all depending on what kind of automation you have based on that protocol they use. In electric utility, you will see Modbus 104 protocol, that is the 104 protocol, IC 104 protocol, or DNP3 protocol, or many aspects comes into it. Profibus comes into the picture. So every sector has their own kind of protocol, and based on that, they create the entire automation. That is called as OT. Okay, and there is something called as remote terminal unit. So whenever you see a device and which have telematic control or telemetry control, in this case, telemetry, that means the data can be goes on with respect to over the telematic communication, such as the 4G communication, 5G communication, or based on the MQTT protocol. So there are many aspects of the picture. So these devices can be comes into such a where we cannot establish Ethernet communication or any sort of Wi-Fi or something. So in that case, on the remote area, that would be possibility we can use what the RTU in this case. Same, you can program it. There are a lot of OEMs are there. So when you talk about these OEMs, they made up some sort of PLCs and which have the antenna behind that particular thing, and it's kind of be a modular as well. If they want, they can attach that modem, the 4G, 5G modem, and they can communicate over the 4G or 5G communication. Clear? Okay, very easy. PLC, now it's very important aspect comes into the picture. So PLC is nothing but programmable logic controller. So in the device, they have a logic in such a way that the entire process can be automated with the help of logic inside the device itself. How many people know about the Arduino? Arduino, 2 or 3 people? These are the what? Microcontroller or microprocessor? So we are now going to engage with each other. Okay. So what is the difference between the microcontroller and microprocessor? Any? If you are wrong, that's fine. It happens because we learn in the engineering or whatever the curriculum. That's fine. But you guys know about the difference between the microcontroller and microprocessor. Any example that would suffice this answer?
So microcontroller can be like managing something when files and bytes are coming, and processor is basically processing those bytes, how they will work in it.
Both are work same?
Like controller basically manage and processor process the data, the bytes.
The processor also can be managed.
It can.
Then what is the basic difference? I will give you a proper example in Baker because everybody knows Baker day-to life, and some people are driving, some people are not. But I think so license as don't drive actually as part of cyber security, automotive cyber security. Okay, so what I'm trying to say that when you apply a brake, how much it takes time to apply the brake? In milliseconds? That is the important aspect, right? Within milliseconds, the brake need to be activated. Whether it is electric car or ICE or any kind of engine you have, means that engine combustion engine I'm talking about, diesel or petrol in this case. BEV, that is battery electric vehicle in this case, that is electric vehicle. So in the automated ADAS or anything, that when you apply when you press the brake, that means immediately activated, right? It should not be happening. You press the brake and it should activate it after 5 seconds. So the consequences would be a different level in this case. That would be a life threatening in this case. So what do you think if I give you an example of your laptop only? Okay, your laptop is processing everything, and suddenly you run AI, because I'm talking about high-end processor and everything. So what do you think? Immediately you open up the video editing softwares, NVIDIA softwares, and games and everything. What will happen? It's get freeze, right? So it cannot run everything at the same time. It requires more hardware, more capacity. What do you think if they use a microprocessor in the brake? Do you think it will work properly? It can be freezed as well, right? And that's the reason they use microcontroller. So microcontroller can access your memory addresses directly. When you talk about the microprocessor, you have kernel, OS and everything, right? But in the microcontroller, you directly talk to the memory address, and that's why you need fast communication. So in the microprocessor, you have layers, right? And the layers, you have to talk from the OS to the kernel, there is a layer, right? Or peripheral, OS and the kernel, if you go from outside to inside in this case, or inside to outside, kernel, OS and the peripheral. But in the microcontroller, you have peripheral and the microprocessor, micro memories in this case. That kernel, or rather you can say ALU, CPU in this case. So it will direct communication, and that's the reason they use the microcontroller rather than microprocessor. Otherwise, sometimes you see the infotainment system, it gets freeze, and that's why they use what? The microprocessor in this case, right? Rather than microcontroller. That's the biggest difference actually. And nowadays, the PLCs, RTUs, and HMI comes with microprocessor as well. So that is an interesting fact nowadays. So the attack vector, whatever you are applying on the microcontroller and microprocessor, both are different. Those are attack vectors are different. So you have to understand the basic things. Okay. So if you attack on the Ethernet with the microprocessor, somehow you can manage. But the attack on the Ethernet with respect to microcontroller, you take down immediately. So you understand my point. Okay. So that is very important aspect we have to learn over here. So the PLC has a different kind of ladder logic program, and based on the IC 61131-3 programming language, and based on that you can automate everything. So we'll see one of the PLC we have, and we coded in this circuit. This PLC looks like, so we have a we have power 24 voltage, depending on 12 volt, 24 volt or 48 volt, depending on what kind of IO you have. I mean to say input and output in this case. So if you apply 5 volt and if you apply 24 volt, what is the difference? Anyone from electronic or electrical background? No? That's fine. So if you have 24 volt, so your data can transfer a long range. If you have 3.3 volt or 5 volt, the way you run the data or stresses are short range. For example, if you open any kind of PCB board and you see 3.3 volt, 5 volt, that means the distance is very less, right? And if you have 24 volt, that means that you can range it 1 meter, 2 meter, 3 meter, 10 meters. And that's how 48 volt, 72 volts, that comes into the picture. Very basic things actually. So you can understand the logics behind the embedded systems. So here input terminal we have programmable coding. You can do it with RS-232 protocol or over the Ethernet as well. These are the batteries and many aspects. So these are the input where you can actuators. We'll see what are the actuators and other things, push buttons and everything. And you have indicators over here. Something happened. It gives only if you do some sort of work. You can see the output over here. And this is what the typical architecture over here. In this case, so nothing but you see the SCADA masters, HMI, and over the communication. Communication can be Ethernet based, communication can be some sort of TCP/IP, rather Ethernet, and wireless communication. And these are the SCADA, RTU, sensors, and actuators. There's nothing but everything is connected with the SCADA and the over the communication it works. So let me check. We have internet. So I would like to show you one, very interesting fact, which is very important and basic one actually, where we are targeting at. Because we are talking about this is Purdue network or diagram in this case. So Purdue model, okay. So let's see this one. Okay, so here there are some layers, level 1, level 0. So level 0 is the physical process, okay. So in the level 0 we have some sort of field sensor, these devices. Let's consider as the temperature sensor. So the temperature of the entire systems need to be captured by the sensors, and these sensors go to level 1. Okay, that is called as controller network. That means your PLC in RTU comes into the picture. And after that, we have level 2, which can be a HMI comes into the picture. Okay, and these HMIs now 2 by 3, or rather you can say 2.5 over here. We have some sort of other applications like domain controller, historian, because they need some sort of workstations in this case. Some sort of engineers need to be sit over there and to monitor or check or need to do some sort of work. This comes into the level 2.5 in this case. And 3 level is kind of the entire SCADA systems or some sort of DMZ. This is with respect to another diagram. And level 4 and level 5 usually comes into the enterprise zone. So that means your head office comes into the picture. Let's say this is the entire building is nothing but the level 1, level 2, and level 3. So level 0, the sensors comes into the picture, that room temperature, let's say, and they have controller, let's say the PLC they have controller, and then everything is controlled by local HMI, and then 2.5 they have some sort of database with respect to that. So if you see the firewall here, can you see the firewall on the level 1 and level 2 here? No, right? So if someone have a firewall, they have unidirectional diodes and other things. That is the different aspect. But if you put the firewall, if something goes wrong and you blocking essential protocols or essential works in this case, So that creates a problem in this case. Okay. So that's what the things over here. So this is the typical architecture over here, and this is what how the entire industrial control system is connected with the electricity, oil and gas, food, beverage, and these are the some sort of inputs and outputs where we have indicators and we have some sort of the PLC, and these are the outputs over here. Sorry, these are the inputs and these are the outputs over here in this case. So communication protocol, this is one of the well-known protocol in the industry, is called as the Modbus. Modbus is created by Modicon, okay, and now it's become Schneider Electric, and they invented in 1979, and this is a royalty-free protocol, and a lot of industries are working on these protocol itself, and this is one of the standards for the industrial communications. So if you see how this protocol works, is based on the master and slave. So if it is serial communication, so we talk about RS485 or RS232 protocol, and if it is TCP/IP, they use the entire TCP communications. So if I talk about the Modbus communication, as I said, it's a master and slave protocol. Master must regularly pulls the data from the slaves actually, and the master Modbus addresses are 8-bit long. And the security flag, it's a clear text and no authentication. That is the biggest vulnerability in this protocol. So you can perform many aspects. These are the some functions where you can see the functions for I mean to say this is the function actually, function 1, function 2, function 3, function 15, 16. So this is what you can read the coil for function 1, function for 1, read the single coil, multiple coil, register for 3 and 6, multiple register 16, and multiple read and write registers. So when we talk about register, let's say, take an example of analog value in this case. Analog value, that is your temperature from 9 -1, -2, or range to 100 degree in this case. And when it gets coiled, that is nothing but binary 0 and 1s in this case. Okay, so I'm going to connect here and will show you the and we'll switch it to a different laptop. Okay, here so we have PLC, okay, and we have some actuators over here, and this is our power supply. We gave power supply to that particular PLC. Now, can I switch to this laptop? There itself, is it possible?
Yes. Yes, sir.
Yeah.
Can we call the person?
We have it here. So in this case, if we push any the green button, it will pop up, or rather we can say it can blow the entire indicator over here. So here, please show the SCADA system. So we have two screens over here. So this is what the SCADA application over here we hosted, and our PLC is connected over there. So if I press the green button, which I shown you earlier actually, so if you press, so it start the fan actually. So it's, so just understand that this is the wind turbine actually in this case. And in this, the Purdue diagram actually, what we are attacking level 1 and level 2. Okay, level 1 and level 2. So let's say from the level 4 and level 5, the malware infected the entire network, that is OT network, and it comes to level 1 and level 2. That happened earlier as well. And it's happening from 2010, the part of TuxNet actually, and that is what we are going to demonstrate over here. So now the entire communication based on the Modbus communication, and every device with respect to OEM, they have some sort of memory addresses which are allocated for the Modbus communication. And if you change into the Modbus communication, that memory address, that will affect or that will change the logic behind the controller itself. So as I said, the logical control programming language LDR we have to use. So let's say we have to scan. Let's say we are dropped into the level 1 and level 2 infrastructure, and we are manipulating the entire communication itself. And our objective is to stop the entire thing. Okay, so because you don't have the access to the SCADA system, this access can be found into 2.5 layer or 3 layer. For demonstration purpose, we are showing you the fan is running over here. So let's start. We have to do some sort of the scanning. We have to read the values because we understood this is the PLC, and PLC is from Delta actually. So we are using Delta PLCs. It's cost over 56,000-70,000 rupees. And now we are going to read the memories. So this is the command mdt get. It's very, you can create your own script as well for this. If you do mdt get -h, so let's understand the commands actually. So just give me that. So you can see over here R1, R2. Just enter 3 times. Okay, R1, R2, R3, R4, these are the read commands for read bit, function 1, function 2, what we saw in the Modbus communication, right? Function 3, function 4 for